Hello everyone, welcome to our daily physics problem, day 13. So today we're looking at a problem. There's two pulley system maintaining three masses, M1, M2, and M3. Ignore the mass of the ropes and mass of the pulleys. What is the acceleration of M1 and in what direction? So you might recall the problem on day 7 when there are one pulley system and you want to find equivalent mass. But here is not exactly the case because we need to consider the inertia force here because the reference frame is accelerating and Newton's law only works in inertial reference frame. So I want you to pause the video, try on your own. After you try it, come back to the video and want to see how I did it. So welcome back guys. So first let's lay out all the forces here. First we have the gravitational force for each of the particle, each of the blocks, M3, M2, M1G. Then we have our acceleration because M1 is accelerating downwards, so the rope is accelerating upwards. Then we all have an inertial force because the acceleration is upward. There's an inertial force pointing downwards, imaginary force that we find out as M1A and M3A and M2A. Then we also have the tension in the rope. We have tension on the upper rope. The tension is down rope. Down rope is T1. The upper rope is T2. So these are all the forces that we need. Now let's look at the relationship. First, it's pretty obvious. We can see that the tension T2 have to equal to 2 times T1, the double of T1. From the left hand side picture you can see. Then let's find out, we know the acceleration of the second block and the third block have to be equal in magnitude and opposite in side because they're connected by a rope. Then we find A2, let's use force divided by mass, force equal to mass of acceleration. Then we know A2 and A3 will lay out the force and equivalent them each other, put a minus sign, don't put a minus sign. Then we multiply both sides by M2, negative M2 and M3. So we have negative M2 times A plus G times M3 minus T1 M2 is equal to M3 times A plus G times M2 minus T1 times M3. Then we want to solve for T1, so let's move all the T1 to the left hand side and all the M and N and G to the right hand side. So we have T1 times M2 plus M3 be equal to 2 times M3 M2 times A plus G. Then we divide both sides by M2 plus M3. We can solve for T1. Now we know T1, we know T2, it's just simply 2 times T1. And we plug in T1, we can solve for 2. So we have 4 times M2 M3 times A plus G divided by M2 plus M3. So now we know T2. We want to solve for the acceleration of M1 now. We know acceleration is force divided by mass. So what's it? The force acting on M1 is M1G minus T2 divided by M1. That will be the acceleration. Then let's plug in T2 into our equation, which is equal to, because M1 and M1 cancelled out, we have G minus, boom, plug it in, times then let's simplify this equation because we want to solve for A and there's A in both sides of the equation, so we need to lift out the A. So we simplify our equation. We got A equals G minus 4 times M2 M3 divided by M1 M3 M1 plus M2 M1 G minus 4 times M2 M3 divided by M2 M1 plus M2 M3 M1 times A. Then we move the A term to the left and keep simplify the G terms. We got this expression times A will be equal to, and then because we move we common denominator the factors, so we simplify them. We got these expressions and we can cancel the denominator because they are the same, multiply both sides. So we got A is equal to M2 M1 plus M3 M1 minus 4 M2 M3 divided by M2 M1 plus M3 M1 plus 4 M2 M3. Then we got our final answer here. And we don't know the direction of the acceleration because we don't know the magnitude of the blocks. And we can only know the direction when we know the mass.